Matt, in his presentation, hit upon something which has always been a bugbear of mine, and that is, that's the way we've always done it. Stefan Stansfield from Combine is going to show why that should not be the way forward, particularly when it comes to development in residential sectors, which historically has in England has not really gone down the soil stabilisation route, unlike in Scotland, because we don't do it like that over here. Stefan is now going to tell us why and how we should.
Thanks, Stephen. Thanks for letting me present. Going to give you just a brief insight into, issues we've had over the years, just trying to break into the market. So the slide will go through a bit of a case study and give you a little bit of the history as well. So I'll just run through a bit about CSSL, we are, and a bit of background on us, the challenge we had to get going with this project, and then run through the technical aspects and the conclusion. A bit about us. CSSL are probably the largest soil stabilisation contractor in the UK. We have an impressive modern fleet, including 8 new style Virgin 240i mixers, 3 of the older 2500 SK mixers. 10 of these are integrated machines, means they can spread and mix in a single pass. To complement these, we have recently increased to 9 spreader units. 3 of these are the Rhino Screwmasters, which have a great capacity of 19 cube, as well as a Bell Screwmaster, which is just a slightly smaller 18 cube capacity. All of those are self-propelled. We've got 5 tractor-towed units. We've got 4 CCC rollers, which we're the first to utilise these on the earthworks project in the UK, we've been told by BOMAG. We've got a further 6 HAM 19-ton rollers and 2 graders equipped with total station for super accurate trimming. In addition to this, we will also assess earthworks on contracts where stabilisation is required. We work in all sectors and I've been involved with many major projects throughout the UK, including HS2, all life sections currently on there, with numerous embankment trials already completed to date, as well as many kilometres of access tracks on there. We've also worked on Inkley Point Power Station and still are currently. The Norwich Northern Development Route as well, which was mentioned earlier, which is a bypass where we stabilise site-run soils to remove the requirements for imported stone. And then numerous other projects in the industrial and warehouse sectors, which are just a few examples. We offer a full service from initial assessment to trial pit and sampling of the material, suitability design, testing and advice on the best solution for the scheme. This all provides an environmental and economic benefits for all our customers. The challenge, the use of lime modified fills to improve soils to successfully support commercial structures is widely recognised and adopted in England. However, the use of the technique to support residential structures is not documented. Britpave Soil Stabilisation Task Group have had numerous technical meetings with the NHBC to discuss the benefits of soil stabilisation could offer to the housing sector. To date, this has been without success, even though the process has been widely used in Scotland and has been for some time. We're not sure why this should be the case, as there is already proof in the industrial sector where numerous large steel frame portal warehouses and commercial properties have used soil stabilisation techniques to remove the requirements for piling to support floor slabs and the foundations. Normal techniques is to remove all made ground and re-engineer the soils to the required level to a higher level strength and compaction specification. These projects invariably require super flat floors with minimal settlement allowed. So, tighter tolerances than what I've expected in the housing market. The project team behind the Gifford Lee Retirement Village, we're going to go on to in a minute, in Tattenhall, Cheshire, have been unable to find an example of this approach for residential developments in England. Now, a little bit about the project. Gifford Lee is an inspired group retirement village set in Tattenhall in Cheshire. It was offering 99 apartments, penthouses and other on-site facilities. The village had been developed in phases. The first 2 phases were constructed on vibro stone column foundations. However, the third phase of 8 blocks and 3-storey timber frame buildings presented issues that required a different thinking. The materials excavated from phase 1 have been stockpiled to the north and west on the site of phase 3. This and the oversized fractions made ground and the presence of historic structures, and the pond led to the principal contractor and construction to consider different options, as the stockpiled soils were required to bring the phase to the required levels, and the earthworks operation was required to deliver a competent fill. The contractor being Seddons were working with combined soil stabilisation on another project and inquired whether the line modified option might be suitable for the subgrade to the structures, parking areas and the access roads. Earlier contract involvement, discussions and a site visit ensued, followed by CSSL producing a potential solution to remove the requirement of a piled or vibra stone column solution for the phase 3. The proposed alternative of the removal of all the made ground and any soft natural soils and re-engineered to a required EU 100% compaction and less than 5% air voids of the cohesive soils was accepted. The solution removed the requirements for a vibra stone column solution and saved the contractor time and money. CSSL also used fully integrated mixtures due to the proximity to the previous completed parts of the development, which were occupied to ensure that a dust-free operation ensued. We'll move on to the technical aspects. Upon inquiry and receipt, CSSL fully assessed the site investigation reports and historical data for the site and drew up budget costs for the scheme based on this info. Once the proposed solution was accepted, investigation work started in earnest. CSSL needed further technical assistance and engaged consulting engineers WSP, with whom we have worked with on several projects and built an excellent understanding and relationship. Previous investigations had already established that the stockpiled soils in their current state were unsuitable for reuse as general fill to raise the site to levels for phase 3. The structures were to be supported on a 200mm thick concrete rafts with total settlement not to exceed 25mm and angular distortions no greater than 1 in every 500. The team set out about a further site investigation to characterise the stockpile soils and assess the made ground, the pond area and groundwater conditions to take representative bulk samples for suitability laboratory trials. The stockpile soils were found to be significantly more varied than anticipated. They comprised of very soft through to stiff, sandy gravelly clays with frequent cobbles, boulders, gravelly sands and concrete gravel. Furthermore, based on elevation, the trial pits suggested that a significant thickness of made ground was present below the stockpiles, with several trial pits unable to locate the natural ground and encountered significant perch water inflows in areas. Where observed, the natural ground predominantly comprised of stiff clay with areas of very gravelly sand, both of a glacial origin. Soil samples recovered from the trial pitting were subject to a programme of acceptance testing on various samples, comprising of we did classification testing, moisture contents grading, Attenberg limits, chemical testing, BRE, sweet, TRL 447s, optimum moisture contents undertaken, remoulded CBRs with lime addition, MCV, and also we undertook some swell test monitoring as well. The acceptance testing demonstrated that the soils were suitable for lime modification to achieve the expected requirements of the WSP performance specification. Following design testing, discussions were then held with Seddon Construction with the technical assistance provided by CSSL and WSP team with Premier Guarantee and appropriate building warranty provider, as stabilised solutions are not by any means the norm within the residential sector. They are, however, widely used in the logistics and distribution sector for warehouse floors and external works where loadings and flatness requirements far exceed those required in the residential developments. Both CSSL and WSP have extensive experience in this sector and were convinced that the lime modified option was entirely appropriate for this project. Agreement with Premier Guarantee was achieved with a lump sum price proposed and accepted. Attention then moved from the design to the construction phases. A performance specification was prepared for the works, which provided validation requirements for exposed natural and placed material. The principal geotechnical end product requirements for the works was to provide modified materials with the following properties. Target air voids less than 5%. Maximum dry density was 100% of a 2.5 kg rammer. undrained shear strength of 70 CU. That was immediately after lime addition, and as Rebecca stated again, that lime and time, you will get improvement in that soil. You've got undrained Young's modulus of 18 meganewtons per metre squared, no discernible swelling, and a geotechnical risk register was prepared, which defined construction-related risks, their potential mitigation and risk ownership. CSL and WSP provided part-time oversight and technical support. The validation testing was collated by CSSL and assessed against the requirements of the specification by WSP, who produced a closure report and warranty for the design. A material management plan was produced for the 22,000 square metres of vegetation and topsoil strip. The topsoil was stockpiled on site for future use, and there was 26,000 cube of cut-fill turnover works up to 3 metre deep, with 18,000 cube of that requiring line modification because it sat under the structures or the access roads. The plan also took into consideration the requirements of the groundworkers to ensure that the overall programme was achieved. We pretty much started the job. The groundworker was due in about 2 weeks behind us, so it was critical we got the programme right. CSL were also responsible for the earthworks, and with consideration to our very expensive mixers, the company ensured that the stockpiled and excavated main ground was thoroughly screened to take out the potential damaging concrete boulders and cobbles, and also segregate any organic fractions from the pond area which can interfere with the modification process. Some perch water lenses were also encountered and had to be dealt with throughout the project. The performance specification was produced and adhered to, with testing carried out on each layer. Once the subgrade levels were reached, it was tested for compliance with the specification prior to handover for the follow-on works and the lifting of the fill. Testing, as is the case with all CSL projects, was carried out by an independent third-party UCAS accredited testing house, with results provided directly to CSSL customers. A closure report was also provided by WSP on completion. The material was line modified to dry it out and also to provide added stiffness to the soils and to provide a performance uplift to achieve the EU of 18 meganewtons per millimetre squared, 5% CBR and 100% relative compaction. The line modification works were carried out in 300mm layers, and up to 10 layers were required in the deepest fill areas. The mixers themselves precisely controlled depth, dosing of water and binders to ensure mix compliance and accuracy, and accurately control mixing depth to deliver maximum efficiency and predictability. 20-ton rollers were also used to ensure the 100% compaction could be achieved in plant-intensive operations. The project was carried out in 7 weeks, achieving the required programme. The reuse of previously unsuitable materials eliminated the requirements for expensive off-site disposal, the import of primary aggregates and the requirement for further specialist foundation solutions. This produced significant savings, not only in economic terms, but also environmentally, contributing to the sustainability and corporate ESG, that's the environmental, social and governance performance targets. Some of these charts you can see now are some of the testing data which was analysed at the end of the site to present to Premier. The compaction test provided values of 100% of the target dry density, with an average value achieved was 105% compaction. Average air voids was 1.45%, with only 2 values marginally in excess of the requirements of 5%. That was a 5.1 and a 5.2%, and this was recorded on quite sandy materials. The drains Young modulus derived from 600 diameter plate tests of 125 kilonewton at 125 kilonewton all achieved the 18 EU requirements as well as the 5% CBR. The 5% CBR basically came in automatically if you got the 18 EU, to be honest. Shear veins tests undertaken immediately after compaction of the fill showed undrained shear strengths between 70 and 140 kilonewton with an average of 112 kilonewton per metre squared. Soak CBR tests were undertaken, an average CBR of 16.3% on them, and an average swell of just 0.04 millimetre swell on them on the specimens taken. Chemical testing and organic matter contents were also in compliance with the specification requirements and within the limits specified in BP 62 soil stabilisation, a definitive industry guidance. The conclusion to the scheme: the use of lime-modified fills to successfully support commercial structures are widespread, and WSP and CSL have been involved with several such schemes. The use of the technique to support residential structures is less well documented, and the team have been unable to find another example in England. The earthworks element was required regardless to achieve the required subgrade levels and provide a platform for a pile foundation solution. However, the stockpiled soils were too wet to be placed as a natural general fill. This effectively left two possible options: remove any oversized hard materials and unsuitable soils, add lime and place as general fill, incur the cost of disposal of the unsuitable materials off-site and import suitable fill materials prior to piling. CSL undertook the first option and increased the strength of the compaction regime, which also had the effect of eliminating the piling requirements with a likely saving of hundreds of thousands of pounds for the scheme. The success of the soil stabilisation approach is underlined by the project being underwritten by a warranty provider with the vision to understand and forward the use of soil stabilisation for residential developments. The works at Tattenhall have shown that by adopting different techniques supported by a robust performance specification and validation requirements, you could provide a robust, cost-effective soil stabilisation solution for residential developments that will be fully warranted. The Tattenhall project is one of two firsts: the documented successful use of lime to improve soils for a residential development, and the first such project, we believe, to receive a comprehensive residential sector warranty. Thank you.